Hello everybody, my name is Cătălin, and today I'll show you a very high-level presentation about how to build your own SIEM from scratch with open source software. We'll start with a few words about myself. I worked for a couple of years for CERT-RO, which is the National Computer Security Incident Response Team. There I've been a security jack of all trades. I've been also a PHP developer, incident responder, everything that was needed. I would have to do it. And then for a sporadic period, I worked for ING as an auditor. Now I'm director of technology at Cyborn and solutions architect. We are cybersecurity startup here in Romania. A security operations center based in Bucharest and with offices in Italy and Washington. Why information security? Well, because it's cool, basically. But other than that, because it's not a matter of if something is going to be broken, it's a matter of when. And we all know that incidents happen, and they will happen sooner or later, so it's better to be prepared for that situation and to know what to do in case of something going wrong. Let's get to the point. Open source versus commercial. First of all, does everybody know what SIEM is? Okay. SIEM is Security Information and Event Management. It's basically a software solution that grabs all the logs in a network, all network logs, application logs, and correlates them to find anomalies and to find behavior that is not supposed to be there, to find incidents and break-ins. The difference between open source and commercial is most of the time support. So most of these open source solutions have all the functionalities of commercial ones, like unified log management. You can get everything in just one place, in one big database. You can have scalability. You can do it for a really small company with just a couple of servers, or for big companies with thousands of servers or endpoints. You can have correlation, and in some cases, if you're really into it, you can also introduce machine learning with it. High availability with redundant clusters, and also vulnerability management or ticketing, stuff that will take your solution more into a security operations center zone. Why do I say it's never entirely free? Because it costs you a lot of time to put the effort into building a solution like this. And as we all know, time is never free. Components of a SIEM are plentiful. You need to take into consideration log sources, which are all endpoints and servers in the network. You need to take into consideration parsing of logs and storing them in order to keep them safe from intruders, because if you don't keep the logs safe, then somebody can have access to the information of all your network in just one place. Alerting is just a way of querying the database and finding things that are wrong. Threat intel, which means correlating what you have in the network with data feeds from internet with known vulnerabilities, known attacks, or other indicators of compromise. Ticketing, if you have a bigger team and want to work with, let's say, operations team or people on the field, vulnerability scanning, and vulnerability management. All of these software pieces have open source variants and also paid ones. So even if you want to do it for a small company or just for yourself in a lab, you can do it. But if you go big, you probably need support and somebody to talk to in order to get I don't know, courses, classes to learn stuff and support for implementation. And most of these also have paid support. We'll take each of the parts of it and go into depth. For log sources, we have beats as the main component. As I talked the previous slide, we think Elasticsearch and the Elastic Stack is one of the best frameworks for doing such an endeavor. So beats are endpoint agents that get installed on endpoints or on servers and get data and push it to the database. We have file beats, which get data from files. We have WinLog beats, which get data from Windows events for Windows servers or Windows endpoints. Packet beats that do traffic dumps and listen on network interfaces. We have audit beats, which can monitor folders, for example. If you have an app that is in production, you can monitor the folder that holds the app and see whenever something new appears there. Whether it's a pull from the developers or it's some code injected there, you can see the modifications and raise an alert based on that. There are also metric beats, which monitor the machine metrics, like CPU usage, memory usage, and this can be useful in finding malware that is, for example, in memory malware, finding anomalies in the metrics. Also, very important, having some IDS data like Snort or Suricata, which have both open source alert lists and also paid ones. And OSSec is an endpoint agent that monitors for malware. Going further, we have the data now. We have to parse it in order to put it in the database. We can use for that Logstash, which is a very powerful tool and that supports advanced pipelines. It can get your data from all the sources. It can get it from beats or just from SNMP feeds and put it on a common format that will get stored in the database and make it easier for you to visualize it. It's very important at this step to do a normalization of the data in order to have it all in a easy viewable format. And for this you can use the Elastic Common Schema, which is currently in beta, but it's very close to production, and it includes the most common fields. You can have predefined fields for all logs from Linux, Windows, and the most common applications. All you have to do is run them and go put them through Logstash and then into the database, and it will get mapped to their fields, and then you can go and make your own visualizations, as I'll show you in a later step. For appliances and special logs, you can use grok filtering, which is a tool built by Elastic in order to parse. It's some sort of a regular expressions format, and it helps you parse any kind of log and put it on the common schema. A very interesting thing about Logstash and Beats is that they both have queuing mechanism inside of them. This way you don't have to add another layer of protection in between. If any of the endpoints goes down, or if Logstash or the database goes down, they have their inside in-memory queue or persistent queues, and they'll hold as much as you want them to hold. I've tested it with gigabytes of data, and they held them and then pushed them to the database when it was up and running again. Now the database. The database in our case would be Elasticsearch, which is a very versatile search engine, actually it's called. It's scalable, it has high availability built in. It's written in Java, and even though it requires a lot of RAM, it can be installed and run on 2 gig of RAM machine. So if you want to test it and build an environment like this, you can do it on a virtual machine without a problem. Unfortunately, there are 2 versions, the open source one and the XPack one. The open source one doesn't have security built in, and other interesting functionalities like machine learning or graphs. But some of them you can do with open source alternatives like SearchGuard, which is a very good security tool for Elasticsearch security add-on. It adds users, accounts, and secure traffic. When you start, it's always better to start with at least 3 nodes, because this way you'll have high availability from the start, and it's really easy to configure them to talk to each other. And whenever one of them goes down for updating, for example, the other ones will be still up, and they will synchronize as soon as they're all online. Analysis and visualization. For this, Kibana is used. There is a nice demo of Kibana online if you want to take a look at the power of the whole infrastructure. demo.elastic.co/app/Kibana. There are lots of data there. The very good thing about this is that besides discovery mode, where you can see the logs and go through each event, and you can do analysis on them, and forensic analysis, for example, after an incident. You have the visualizations and the dashboards, which are not only cool for us, but are very nice for management, because they always want to see nice pie charts. Also very interesting is that as long as you have all the data in one place, you can do lots of business use cases on that. You don't only need to do security. You can, for example, if you have a web server and you have a website, you can do all types of analytics like you would do with Google Analytics. Or if you have another app that cannot be run through an analytics app, You can see dashboards here with usage. You can see also availability on the operations side for network and everything regarding availability. Um, Going further, the alerting part. For alerting, a nice tool is 411, which is a tool built by Etsy, a very big marketplace for manufacturers. It's it's got a nice interface, and the thing that it does is it runs queries on the database in order to find anomalies, and you can set up searches here, searches that are being run on the database as often as you need them to. The good thing about 411 is that it's written in PHP. It's very easy to configure and to add plugins to it. It can be easily customizable, and it can alert you via email or Slack whenever something happens. It also stores all the data it generates also in Elasticsearch, so you can do dashboards with the alerts as well and reporting on that. It has reporting built inside of it, but it's very primitive. It only has active alerts and closed alerts, but it also has interesting incident management option. You can add comments to the alerts and close them with resolutions. This is very foggy, but here you would be able to see this is the panel where you can create searches. You can just add the query in for Elasticsearch. Say what you wanna search for, and add information like how often you want the search to be executed, like every minute or so, and time range for the query. It can alert you if there are specific fields in the database, if there are no fields present regarding that query, or can just count them and see if they reach a certain threshold. Threat intel. For this, MindMeld is a very interesting tool. It correlates all threat intel feeds. You can add. It comes by default with some open source feeds. It's been developed by Palo Alto Networks, and it's open source on their website. You can install it and have access to open source feeds out of the box, and you can synchronize it with Elasticsearch, so you have all the data in one place. Afterwards, for each event that comes into the database, it can be synced to the threat intel, and you can see if it's something of interest, if it's something that that somebody else found before you. For example, file names or URLs. Sources for the threat intel include Alien Vault, OTX, Spamhaus, and various other free sources. These are the optional steps, which are ticketing, for example. This is a very nice but also very frustrating tool. It's called Request Tracker. I see somebody in the back there that has a lot of experience with it, and a lot of mixed feelings about it. Anyway, you can integrate it with the rest of the infrastructure so that tickets get created automatically whenever a new alert is raised, and then you can send it to whoever is in charge. The only downside that I see to this tool is that it's written in Perl, so it adds to the overhead of knowledge that you need to have in order to set up all this infrastructure. I'm curious, does anybody here know of a ticketing app built with PHP? Like a serious? Nope? No, me neither. Yeah. Okay. Facebook? Yeah, that would be cool. I don't think Facebook is written entirely in PHP anymore, but I know it started there anyway. Vulnerability scanning. Obviously, everybody knows about Greenbone and the OpenVAS. It's an open source vulnerability scanner. It's not perfect, but it works, and it gives you reports on the assets in your network. It can export CSV, XML, or PDF reports, which can then be synchronized with your vulnerability management app. And vulnerability management, for vulnerability management, I found this tool, this open source tool, that is still under development, but it looks pretty promising, and I think it works. It's worth taking a look at it. Archery, it's called. It's vulnerability management software designed to keep the scans all in one place and designed to give you an overview of whatever is in your network. It can be integrated with also with network scanners, but with application scanners as well. So you can see everything in one place, even if you use Nessus for one part of the infrastructure, OpenVAS for another, or I don't know, Acunetics for your web apps. As I said, it's still in development, but it's under intensive development with commits almost every day. This was my presentation. If you have any questions regarding this whole infrastructure.
So for any questions, here's a microphone.
Yeah, first question. So the thing is that at the beginning you said that one of the steps in order to create your SIEM is to cluster the data. But for instance, if you are getting only the network information from your, I don't know, personal router at home or something like that, how would you clusterize the data inside? I mean, what would be the main categories to be translated in?
Oh, you mean the common fields? Or I was talking about, I don't know if it's on the,
Yep.
Nope, it's not here. I was talking about the elastic common schema. That's a set of fields that come into the database, and all the logs it's like a table header, if you want.
Okay.
And I think it's important to have everything under the same header, the same columns, so that when you do visualizations, you can have a visualization based on source, or you can do pie charts or stuff like that. And including the home router, if it generates logs, it would probably generate, I don't know, a CSV that has a table header.
Okay.
Thank you.
Hi. So I have a comment about this. Elk is nice to start a SIEM with, but I think it's missing one important part, the correlation engine, because you have to do like a lot of development work.
Yes, 411. I was talking about this.
I don't have experience with that, but I'm curious, how competent is it? I mean, does it do moving averages? Does it do? You have to move from moving averages, moving windows. You have to move from atomic events, from single events, to something more actionable. So.
Well, if you can write a query for it in Elasticsearch, you can put it here.
Debatable, but yeah.
Yeah.
Thanks.
problem.
How many agents do you use from this solution?
Out of the ones that
You speak
I
a lot
spoke
of
here.
bits agents, for example.
All of them.
Do you use one agent or all these agents?
For each.
Collect information.
Well,
You need
it
to
depends.
collect information,
Yes.
and for this you need agents.
Yes. Well,
How many agents do you use?
It depends on the one for each host, basically.
Okay.
But it depends on the host and the scope of the host.
Hey, so my question is, what's your approach towards monitoring containers, if you have one?
Well, it depends. Most of the containers can generate logs and they can generate logs outside of the container on the host. So you can grab those logs and parse them.